This is N. Kishore of Artificial Intelligence and Data Science Department studying in Janssen Institute of Technology, first year, semester 2. Now I'm going to discuss about the topic of my case study. Yttria stabilized zirconia is a supersonic conductor. Introduction. Yttrium stabilized zirconia has long been used as electrolyte in solid oxide fuel cells. The specific grain boundary conductivity in polycrystalline electrolytes is usually at least 2 orders of magnitude lower than that of the grain bulk, leading to a blocking effect of oxygen ion transport as well as lower ionic conductivities at low temperatures. In order to improve the conductivity in grain boundaries, the optimization of synthesis process for such materials is of great importance. Materials and methods. Surface morphology and energy dispersive X-ray analysis. The Raman spectra were recorded. AC conductivity was measured. Result and discussion. Raman measurements were performed in order to clarify the identity of the crystalline phase in these films. The Raman spectra of oxide ceramics typically contain a large amount of information extracted from the band position, their intensities, and their shapes. Result and discussion. The presence of stress in the network can cause the shifts of the Raman frequencies. Therefore, the observed Raman shifts corresponding to the different bands can be induced by the residential stress caused by the change in network parameters between cubic and tetragonal phases. Result and discussion. XRD and Raman results evidence a mixture of phase at low concentration of yttrium in the films. In order to relate these results with the electrical properties, the lattice parameters, grain size, activation energy, and total conductivity at 450 degrees Celsius. Experimental. Deposition were carried out in an ultra-high vacuum system. The film structures were analyzed by X-ray diffractions. The sample thickness was mainly determined from the cross-sections TEM and cross-sectional SEM. Lateral ionic conductivity measurements in the frequency range 42 Hz to 1 MHz were performed at temperatures from 500 degrees Celsius down to 150 degrees Celsius in steps of 50 degrees Celsius at a dwell time of 40 minutes in order to evaluate possible substrate contributions. Conclusion. These results indicate that the high conductivity of nanostructured ionic conductors is a consequence of different physical parameter in the films. Therefore, the stress in the material, different crystalline phases, impurity diffusion to the grain boundaries, and the presence of electronic conduction can all affect the electrical property of the nanostructured thin films. Thank you. By N. Kishore.